Hello students, in this video I will go through exercise U2A05 where we will be applying concepts of rotational and reflectional symmetry. Alright, let's take a look. Which geometric figure has one and only one line of symmetry? So, looking at this right now, I have an isosceles trapezoid. That is a line of symmetry. And I only see one. Here we have two lines of symmetry. That's a rectangle. Here we have 1, 2, 3, 4 lines of symmetry. This is a rhombus. So a rhombus is actually made up of 4 congruent congruent right triangles. So actually we have 2 lines of symmetry there, and that's it. So the only one is isosceles trapezoid. Which geometric shape does not have any lines of symmetry? Which geometric shape does not have any lines of symmetry? That would have to be this parallelogram here. Because if I draw a straight line down, horizontal, even diagonal, nothing, there's no line of symmetry in a parallelogram. Which diagram shows a dotted line that is not a line of symmetry? So this guy is indeed a line of symmetry. So is this. So is this. Not this guy. Right? Because if it was a line of symmetry, then that S would end up looking like that. Okay. How many lines of symmetry does the accompanying figure have? Let's see here. So this is a line of symmetry. This is a line of symmetry. This is a line of symmetry. So is this one here. So I see 4. Are there any others? Are there any other line of symmetry? Is there an infinite number of line of symmetry? I don't think so. No, I think that's it. Which graph is symmetric with respect to the y-axis? This is definitely symmetric about the y-axis, so this one works. This one's not. Nope, not this. Nope, not that. Yep. Helen is using a capital H in an art design. The H has only one line of symmetry. No, that's not true. Only 2 points of symmetry. 2 points of symmetry. That's not true either. I believe H has 1 point of symmetry, 1 point of rotational symmetry, and that's right in the middle there. 2 lines of symmetry and only 1 point of symmetry. I believe 3 is our answer, but let me read number 4. 2 lines of symmetry and 2 points of symmetry. Yeah, definitely number 3. There's no second point of symmetry that I can see here. But if I'm wrong, you guys can correct me here. Let me take a look at number 6, what their solution is. Number 6, this is actual Regents questions, actually. Let me see here. So question number 6 says it's option 3. So is that the case? Yep, that's what I chose. Number 7, which letter has point symmetry? H has point symmetry, and none others. Which letter has both point and line symmetry? Point and line symmetry. Again, H. Z has point symmetry, but not line symmetry. T has line symmetry, but no point symmetry. C has no symmetry at all. Actually, no, I take that back. Has line symmetry only. Which letter has both line and point symmetry? Line and point symmetry. It's the same question. Which letter has both line and point symmetry? It's the same question. So H. Yeah, I don't know what happened there. I don't know why it repeated itself like that. Which letter below has point symmetry but does not have line symmetry? Has point symmetry but does not have line symmetry. So that would be letter N. All the others don't. Which letter has point symmetry but not line symmetry? Has point symmetry but not line symmetry. has point symmetry but not line symmetry? I believe that would be S then. Which letter demonstrates line symmetry but not point symmetry? Which letter demonstrates line symmetry but not point symmetry? Line symmetry but not point symmetry. So that would be T. Which shape does not have rotational symmetry? Which shape does not have rotational symmetry? Trapezoids. Regular, any regular polygon will. Circle definitely does. Square definitely does. Because square is a regular polygon, so that would leave us with just the trapezoid. Number 14 reads, on the accompanying square, draw all lines of symmetry. So that's 1, 2, 3, 4. And that right there is a point symmetry right there. Draw all lines of symmetry on the accompanying shape. So I see there's this, and I believe that's it. Describe the kind of symmetry that exists with the following figures. If there are line symmetries, describe how many line symmetries. Likewise, with rotational symmetries, describe over how many degrees will result in a rotational symmetry. So these are line symmetries, and there are 4 of them. So 4 line and 1 point. And what is the in other words, what's the magnitude of rotational symmetry? That would be 90 degrees. Right. Okay. There are 2 lines of symmetry, and there's 1 point symmetry. And this would be 180 degrees. Here there's definitely a point symmetry, and the rotational symmetry for that to happen would be 360 divided by 5. That would be what would that be? That would be 72 degrees of rotational symmetry. And how many lines of symmetry? There's 1. There's 2, there's 3, there's 4, there's 5. Are there any others? Nope. So there's 5 lines of symmetry and 1 point symmetry. Here there's 1, there's 2, there's 3, there's 4, there's 5, and there's 6. There are 6 lines of symmetry. There's 1 point of symmetry. And what is the magnitude of rotational symmetry here? I want to take 360 divided by 6, and that would be 60 degrees. So I would rotate 60 degrees for it to land on itself again. Regular septagon, 7-sided shape. So this is a line of reflection. 1, 2, 3, 4, 5, 6, and finally 7 lines of symmetry and 1 point of symmetry. And what is it's 360 over 7, and now that's not divisible, but it is going to be 51 3/7 of a degree. Okay, I have a regular octagon. So going by the pattern here would be 8 lines of symmetry, 1 point of symmetry, and it would be 360 over 8, in other words, and that would be 45 degrees. And now here we have an n-sided polygon, so there will be n lines of symmetry, 1 point of symmetry, and it would be 360 over n degrees. That would be the magnitude of rotational symmetry.